I have another oven control board that was sent in by a customer. For this one, it's going to be a little different. The customer stated their control board was completely fried. So when we look at the other side, indeed, we have a lot of burn damage over here. So let's go ahead and take a look and see if we can fix that. Looking under the microscope, we can tell there is a significant amount of damage in this localized area, but there's not really much damage anywhere else, just a lot of smoke. So looking around, we're gonna probably just need to do first a cleanup, get a better idea of the extent of the damage, and then go from there. If we take a look at the backside looks really clean. So there's really not that much damage back here. So it's really on that front area that we have to clean up and deal with that damage on this side. We're gonna start with a Q-tip and some isopropyl alcohol and just clean up as much of that burnt material as we can. So after cleaning it, it looks a lot more localized now, and it looks like the component that was here between this leg and this leg has completely burnt off. And this little piece was the last piece remaining that was still on the board. It did fall off as I was cleaning. So this is going to be kind of hard to identify. And without cheating, using a good board, I don't actually know how I would identify this. Luckily, I do have a cheat board that I can use. So this is our cheat board, and clearly we have a resistor in place right there, so R41. So it looks like it did fail and burned up, so we're gonna have to go ahead and replace that component. So first let's measure it and check out what resistance it is. So this resistor seems to be a 5-band resistor. I'm seeing red, brown, gold, and white over here. But when I go to the resistor calculators online, that's not an option for white as the last band. So doing a 4-band and pretending this white one is not there for some reason does seem to work out better. And I can get a red, brown, gold, which is supposed to be 220 ohms. And using my multimeter, we are getting about 219 ohms, which is the 220 we're expecting. Now I do have a replacement 220 ohm resistor, but it is significantly larger, which is going to be okay. This is just a higher wattage resistant. So this is just a higher wattage, but it is the same resistance. So that's what we use to replace on the defective board. Now the component is missing, but the legs are still soldered on the backside. So we are going to want to go ahead and remove those legs so we can go ahead and install our new resistor. I'm gonna just pull that through. There we go. Go ahead and do the same on the other side. Alright, and one of the things I'm going to do here is actually using the scratch pen. We're going to expose a little bit more of the copper because some of our pad is missing. And I want to make sure that the replacement resistor does have very good contact with this trace. I don't want any cracked joints or anything like that that could cause any more problems in the future. So we'll go ahead and feed the replacement resistor through. Alright, and then we'll go ahead and clean off the rest with a toothbrush. So I guess now what's important is understanding why did this happen in the first place and how do we make sure it doesn't happen again. So to understand a little bit better, we're going to have to look at the board a little bit closer under the microscope, again on the back side. So one of the most common issues we see with oven control boards is cracked solder joints. When that happens, that can cause arcing, which causes a lot of heat and will cause this resistor to burn up like it did. So if we follow it to this joint over here, we can see it has a ring around it, which is a cracked solder joint. When we zoom in significantly more on it, it becomes very apparent that we have that ring around it of that cracked joint. So there's not proper contact occurring. So this is the most likely reason why our resistor failed in the first place, is because that relay had a very bad cracked solder joint that caused some arcing, more power draw, more heat, and then the resistor eventually failed, completely burnt up. So when we look at the rest of the board, there's other areas like this one over here where we can see there's the beginning of another cracked solder joint over here. And looking at some of our other joints, those look okay. And these are also okay, although I can see what looks to be like the beginnings of a joint that's cracking. It does look like we're getting the start of a cracked joint here. So while we do have one that's very obvious, we are going to want to reflow that entire board to make sure that there's no repeat failures. One thing I'm actually going to do is remove all of the old solder and put all fresh solder. I don't want any of that potentially burnt solder to not flow properly and not make perfect contact. And then the other joints that are not cracked, I'm just going to add a little bit and just reflow them. So it does look like we have yet another successful repair. The resistor issue should not come back, at least not for 7 to 10 years, until those cracked solder joints do eventually come back. There's not really much that you can do as a user to prevent that, aside from just not using the control board. This is a problem that occurs on a lot of different ovens, and that I'm aware of. Yeah, there's really just nothing you can do as a user to prevent that from happening. So we can resolder it, we can fix it. You're going to have another 5 to 10 years, 7 years, I don't know, out of the control board, but eventually it's going to happen again. So if you have any questions, let us know in the comments below. If you thought the video was useful or helpful, leave us a like, and for more content, go ahead and subscribe. Thanks for watching.